Hello everyone, welcome to my another exciting BGP video. In the past video I recorded earlier today, we configured this topology for eBGP and iBGP, and we also configured OSPF as IGP. And after the configuration was done, router 4 was able to reach to router 5 this way, eBGP, IBGP here, then eBGP. Even though they did not have direct connectivity, the router 4 was able to travel all the way through this like this, and able to communicate with router 5. So that was pretty detailed video. If you haven't seen that video, I would suggest you to go back and check that video. So I want to take this to another level, another step. So I want to add more topology to this. Imagine this is your data center 1 on the top, and you would also have a data center 2 on the bottom here. So using the same topology, I just want to configure. I just want to take this configuration to a next level and get more deep, more further deep into the BGP world, right? So what I did basically, if I'm calling this as a data center 1 and this is data center 2, I just plug in a router 6 here. So basically a router 6 has this network 6.6.6 and 66.66.66.0, so and so. So router 6 will be in so in this configuration we are not going to configure anything till here. This is already configured. I'm just going to configure router 6, which I already did. Now we'll just take you all to router 6 and show what we have here. Basically we have point-to-point connectivity from this interface to this, and same point-to-point connectivity from router 5 to router 6. So if I do show IP BGP summary, there you go. So I have 142.168.1.1 as my neighbor, 162.168.1.1 as also as my neighbor, which is pointing respectively to router 4 and router 5. And I'm also learning all of those prefixes. So if I do show IP route here on a BGP, basically I have routes, or I have advertisement to all my loopback interfaces hanging on to all the routers 1.1.1, 2.2.2, and so forth, so on. I also have full connectivity to my entire network. So imagine this guy is sitting on the edge of the data center 2 router 6, so I'm able to reach to the router 1, which is sitting in front of the data center 1 as an edge router. So I have full connectivity across the network. If I have to ping to 3.3, I can. If I have to ping to 2.2.2, I can. Alright, so now in this video what we're going to do is, let me clear this a little bit. So we will see router 1, how router 1 is receiving this 6.66 routes. Through which interface is it learning through this way, or is it learning through this way? First we'll do that, right? So a simple way to do that is I will hop onto the router 1 and I will do a trace route 6.6.6.6. So I will see how router 1, which route is taking to reach to the data center 2 router 6. If I do that, I'm 192.168.1.2, 172.158, 142. So basically it's taking 172.158 from here, 142.168.1.2, going here this way. So like tomorrow your management say you want, for now this is the primary, right, and this is the secondary. So say like tomorrow your management said no, due to some reason, maybe these WAN links are not good, maybe they are under heavily utilized or something, they want to make this as a secondary and this one is a primary. They want to just flip it around, right? Just change the role. So how would you do that? If I do this, same thing, right? If I do a trace route to 1.1.1, it will take me the same way, 192.168.150, 172.168. So it's taking it this way, but the question was how I'm going to switch from here to make this one as a secondary and this one as a primary. If I go here, so we want, when I do a trace route to 6.6, I want it to take 192.158.1.0 as a primary, and 172.168.1.2, then 162.168, which is not doing it as we speak. So there are multiple ways I can do. Some of them are like configuring AS path preference or local preference. So in this video, at least we will go and configure the local preference, and we'll do the BGP load balancing there. So we'll make sure instead of taking 192.168, this pair, it should take 192.158.1.2. All right. So first thing first, what I would do. Step one would be I would create a prefix list. So IP prefix list, I will call DC2, right? Sorry, prefixal sequence 10 per minute. So I will just add the my data center 2 prefix, right? I will just change this. We have two prefixes at least, two networks 60.60.60.60. Oh, sorry, sequence 20. All right. So do show. Let's confirm what we just configured. Alright, so I already created a prefix list. I'm calling in both the network of my data center 2. Right, now we'll create a route map. Route map, I'll call it R6 because, or let's say DC2. Right, route map DC2. I will bind this IP prefix list to the route map. Match IP prefix list. Match prefix list. Match IP address prefix list, and I will call this name DC2. And I will give this command. This is very important, right? Set local preference 200. By default, the BGP local preference is 100, so we will give higher value, right? I will just call 200, right? And put an end to this. Now let's do show run sec BGP. Okay, show run sec. It's upside. It doesn't want to take uppercase. Alright, so based on our trace route, what we have seen is if I do a trace route, it's taking 192.161.2, this route. So what we will do, if you haven't seen my video, what I did instead of using the point-to-point IP address for BGP peering, I used the loopback interface. So basically 2.2 is hanging out to the router 2, so it's 172.168.1.2. This guy 158.1.2 belongs to here, right, on the router 2, hanging on to that. So it's taking this route. So what I would do, we want to switch that to going this way, right, towards the router 3. So I will call this neighbor the loopback interface of router 3. I will go here, router BGP 100, right, and I will call neighbor 3.3.3 route map. Just copy paste the name of your route map. It was DC2. Oh, sorry. So DC2, and you have to give the in. So you have to put this route map in the inbound direction, right? So R6 is advertising the routes this way, right? Also at this way, right? So you have to put that route map here in the incoming direction. So I would do dot in, right? Just end. So show on the BGP one more time to confirm what we just did. Neighbor 3.3. I put this. I put this route map DC2 in, and let's do a trace route and compare with the previous one. All right. So still taking this way. So clear IP BGP soft. One more time and see if. Alright, so after I clear the IP BGP, we basically reset the BGP session. Now you see that 192.158.1.2, this guy, and 172.168.1.2, this guy, and 162.168.1.2 this way. So prior to that, before I put that and reset my BGP, it was taking this route. So I hope this is clear to you all now. How we can use this local preference to do a BGP path manipulation, and this is how you do it. So I want to keep this video short and simple, under 10 minutes. So that's all we have. So please look out for my upcoming videos on BGP, AS path preference, BGP, different ways of path selections, path manipulation. Then I'm also planning to record a video on BFD bidirection forwarding, default route. There's so many things to come, right? As I recall, as I get the time, I will make those videos and upload. So keep looking for those videos. Please subscribe, leave a comment, question if you have anything. And thank you so much for your valuable time, and I hope you have a great day. Thanks.